So this question here, we have one object falling, and it's given by h of 1 is equal to negative 5t squared plus 100. And we have another object that is being shot up into the air at 20t plus 2. So the initial height is going to be 100 for the falling object and 2 meters for the rocket going up. And we're just gonna guess at what point those paths are gonna cross. And we can kind of see that it's got to be somewhere between 100 meters, which is the starting point of the falling object, and 2 meters, which is starting point of the rocket. So I can just plug in some numbers here. I can try 1 at x equals 1. The falling object is going to be at 95 meters. At 1, the height is going to be 22 meters. Well, it's definitely got to be more than that. So maybe we'll go to 2 seconds. T squared times 5 is negative 20. So that's going to be now at 80 meters. And for t equals 2, it doesn't go very high. It's now at 42. And then going to 3 seconds, that's going to be negative t squared is 9 times negative 5 is negative 45. So now we're at 55 meters here. That's fallen to 55 meters. And the rocket ship now has gone up to 62 meters. So the answer's got to be somewhere in between. Okay, so we can kind of try zooming in a little bit more. We can maybe go 2.5. We know it's got to be between 3 and 2 now. So when we put 2.5 in, we get negative 5 times 2.5 squared plus 100. And that's going to give me about 68.75. And then doing 2.5 for the rocket ship. Okay, that's going to be 50 plus, so that's going to be 52 meters. So again, we can just keep going on. We can go 2.8, and we can go on until we get more and more accurate. But we know it's got to be somewhere between 2.5 and 3 at this point. So I'll do one more guess. So 2.8. Okay, so we end up with 60.80, and then for 2.8, we're going to end up with that's going to be 58. Okay, so 2.8 times 20 plus 2 is going to be 58 meters. So we know that it's got to be somewhere a bit more than 2.8 and less than 3. So probably around 2.9, somewhere around there. So we can just keep on guessing and guessing until we get more and more accurate. So we're going to say at this point, we're going to say that t is somewhere between, it's got to be less than 3 seconds. And we know it's got to be more than 2.8 seconds. So it's probably about 2.9. And if we actually graph this and graph for the intersection point here, the intersection point works out to be 2.86 seconds, and the height is 59.16. Okay, so that's going to be our coordinate. So we know that the answer is 2.96 seconds. And the way we got this was we graphed this. So y1, we would have put in negative 5x squared plus 100. And then y2, this would have been 20t plus 2. And that's our intersection point there. Now, if I were to set up an algebraic equation for this, since they're both y equals or h equals, I can just make them equal to each other. So I end up with negative 5t squared plus 100. And that's going to be equal to the other equation, 20t plus 2. Okay. Now, the problem with this, when we try to solve this algebraically, there's a big problem here because we haven't yet learned how to deal with this square. And this one here, it's really awkward to solve it algebraically, but one of the first steps we're going to do when we start solving these later is we're just going to make this equal to 0. So I'm going to end up with negative 5t squared minus 20t plus 98, and make sure you keep it an equation equal to 0. And then we're going to maybe do something with that t squared minus 20 plus 98, that expression there. We're going to do something with it to be able to solve. And this is called a quadratic equation. And we're going to try solving this with a strategy that some skills that we've learned earlier on in the course.